Hey guys, the time has come to Hey guys, the time has finally come for me to finally disassemble the refrigeration system that I've installed into my motorcycle here. It was a really good proof of concept, but in actual practice, after actually using the unit for a year, I determined that my choice of the location for the condenser unit in front of the radiator by the engine and, the exhaust was not a very good idea. When it got up to around 20, 25 degrees outside, when you stopped at a stoplight, which is usually when you actually want this refrigeration system to be, fully functional, it would actually, the compressor would actually fail on high pressure and stall. So, yeah, so that means that the pressure on the high side was getting way too high for the compressor, so the delta P was too high and it couldn't deal with it. So yeah, so what I'm going to be doing here, and I guess I'll take a time lapse of it because I actually didn't take very much video of me building it. So just for, I guess, resume purposes and other stuff, I want to have it have a video of the disassembly. So that's what you guys will be seeing here. Yeah, thanks for following along with the project. And I will be sure to document the next revision where I intend to put into more of a saddlebag form factor with the heat rejection side somewhere over here. So we don't have the issue of the kind of the heat convection from the exhaust. I think that's what was probably killing it earlier. Awesome, thanks guys. See ya. Hey guys, so I'm just about to start the teardown of the motorcycle refrigeration system that I installed. I'm doing this both for personal reference as well as just to show you guys exactly how it was made and all the different issues and technicalities, and also just how I generally designed and built things into the form factor that is currently. I didn't make an initial setup or design video, so this is kind of just to replace that, I guess, per se. So there's actually some reference of what I've done here, or some documentation of what I've done here. Yeah, so most of it will just be a time lapse, at least for now, but I'll try to add in some interesting parts that aren't a time lapse of what I'm doing here. This is the reservoir that I 3D printed. I just used a little Chinese diaphragm pump that I built. Sorry, I didn't build. I got on eBay for like $4. Ironically, it was either this or a $500 British micro pump, which would have been so much better because it have an actual brushless motor in it. But that just wasn't really in the budget for at least this initial revision. I'm probably going to use one in the next one. But it's just expensive, so I didn't want to purchase it. It came with this little controller here to desolder all these janky wires. Nostalgia here. This little three-phase just inverter thing. So it just takes 12-volt DC in and boosts it up to like 20 or 30 volts, and then inverts it and drives a little microcompressor that's located in here. You'll see that later once I remove the side panel. But yeah, progress. I just disconnected the power here. I didn't put a fuse in because I'm kind of special that way. But yeah, of course, revisions. I just want to get this one. This is more of a proof of concept.
The perfect machine.
So, as you can see here, over the year that it's been installed, there's been some rust on the little mount thing that I built. That was to be expected because I didn't paint it, and it's made out of mild steel. It looks like there's some erosion on the copper as well on some of the braze points, which is kind of interesting. The capillary tube seems fine. This is a really weird coupler solution, which was not the best idea in the world. It worked in practice, but I've had it leak a couple times, and I had to get in there with a screwdriver, really weirdly, to repair it. It's just two little pieces of vinyl tubing that were used as kind of like a coupler, I guess, or what's the technical term for it? A bushing, yes? I don't know, I forget. But yeah, so I'm gonna have to remove all the shit here. Somehow unbolt the heatsink, or the condenser, which has taken a good beating, holy moly. Actually, it's not too bad. Got little Delta fans in front of it that kind of worked, but it definitely could have been better. Some janky brazes, which have not leaked, surprisingly. Yeah. It's definitely a very interesting system that I built here. And this is a little tiny compressor. It's basically a little rigid HVAC 1.9 cc compressor, which is tiny and it spins at 1 million RPM. I mean, not 1 million, but like, it goes really fast. It's actually, I just connected the power. But yeah. What the hell? Okay. Well, that was dumb. I hooked up a little low-loss fitting, only to spray POE oil everywhere. What the hell? It's all over my bolts. Oh, shit. That's exactly what I didn't want to do. Interesting little box here. It's just a 10 amp power switch, but what's kind of funny is that it has a 10k pot, but it's just functioning as a variable resistor. It's actually not like a 0 to 5 volt analog control signal. It just changes the resistance. This little control board has a little funny like 10k 0 to 10k resistance detector, which is kind of funny. I just thought it was really funny. Anyway, yeah.
Machine.
it looks like I accidentally snapped off the little fitting that goes into the fuel rail here. It's kind of frustrating. It means I have to order a new part. I didn't expect that to happen. So it smells like gasoline. Looks like an plate. It looks like actually it isn't too difficult to replace. So it's a field serviceable part. It isn't really because I have to get a new throttle body, but that probably isn't too likely. Right, yep. This concludes the disassembly video for the last revision of my motorcycle refrigeration system. Be sure to stay tuned for the next video, which will feature the design and construction process for the next and hopefully fully functional revision. Thanks for watching the video, and subscribe if you want.